Hi. So the first half of this week, we're going to be looking at function notation. Really, this whole week, we're doing function notation, but we're just kind of breaking it up. So I did kind of want to go back over linear functions really quick, just to make sure we're still okay with those, because those pop up all the time. So when coming from a graph, looking for slope, excuse me, I want to find any 2 points that touch at the corner of one of these boxes. So I'm going to pick this one. Actually, you know, I'm going to pick this one and this one. Why not? And then remember, slope is rise over run. So I want to choose like how far up and down it goes, and then how far side to side. So I'm going to count how many spaces I got. 1, 2, 3, 4, 5, 6. I went down 6 spaces. Excuse me. And then I went right 3. So my rise is going to be -6, and my run, yeah. You okay? Sorry, my dog was being weird. My run is 3. So -6 over 3 simplifies down to -2. Technically, you should simplify these if you can. Just because. So next I want to find my intercepts. So that's where it's going to actually touch each axis. So my y-intercept, it touches right there at the point 0, 2. And remember that intercepts are points, so we write them as xy. Then my x-intercept is where it touches the x-axis at the point 1, 0. Now, it asks for the equation. So we found that our slope is -2 and our y-intercept is +2. So remember, equations are written y equals mx plus b, where m is your slope and b is your intercept. So in this case, it's going to be -2x plus 2. -2 for the slope, and then +2 for the y-intercept. So, ta-da. Next, oops, I didn't give myself much room. But I want to make sure that I can write that in slope intercept form. So this is standard form. So if I'm writing in slope intercept form, that means that I'm going to be solving for y. So I want to move my x over to the other side. So I'm going to subtract x on both sides. So these cancel, and then I get 3y equals -x minus 12, because I can't actually combine those because one has a variable and one doesn't. Then I want to get rid of the 3, so I do that by dividing, but remember you have to divide everything by 3. And if there's not a number in front of x, it's just like having a 1. So my equation is going to be -1/3 x, because 1 doesn't divide easily, by 3, and then -4, because -12 divided by 3 is -4. And remember to use fractions instead of decimals, because in general, a lot of times decimals you end up having to round or truncate. It's just more precise if you do the fraction. Okay. So a function. In general, when you're talking about a function, we're going to be looking at mostly like equations today. But the general rule for a function is that actually, let's start here. Functions are made up of inputs and outputs. So your inputs generally, I mean, it can be different letters, but generally your inputs are x. So that's something that you would like plug into an equation. Okay, your output, what you get out after you plug it in, is generally your y. So the general rule for something being a function is that every input has only one output. So if you, like, for example, if you plug in 2 for x, you're always going to get the same number. So like if you plug in 2, it'll always be 5. It won't be like 5 and -1 or something. That's kind of what it is. So function notation is used because it kind of puts an emphasis on inputs and outputs. So normally, like you might have an we're used to seeing equations like y equals 2x plus 7. Okay, where x's would be your inputs and y's would be your outputs. And that's cool. But function notation, instead of putting the y there, it uses notation like this. We have f of x equals 2x plus 7. The reason why this is nice is because it technically gives that function a name. That function is named f. Okay, and then it's nice because then you can also have something like g of x equals 3x minus 2 or something. But they're two separate functions. But now I can talk about them at the same time because instead of both being y equals, they have different names. So when you're, one of the things we're going to be doing this week is evaluating. So what that means is, you'll be presented with something like find f of 2, right? And so what that means is that they want you to take the function f, so 2x plus 7, and they want you to plug in 2 for x. So I'm going to write 2, and instead of x, I'm going to put 2 in parentheses plus 7. And then if I just, 2 times 2 is 4, plus 7 is 11. That tells me that f of 2 equals 11. This is why function notation is nice, because now I know what my input was. My input was 2 and my output was 11. If I just have y equals 11, then you don't see the 2 right next to each other. So if you were looking at a graph of this, one point on this function would be the point 2, 11, because 2 was my input or my x, and 11 was my output or my y. Okay. And then if, let's say I wanted to also say find g of -1, then I would just be plugging in -1 for x in the g function because they each have a name. So in this case, g of -1 is going to equal -3 minus 2, which is -5. And if you're not super great at mental math, use a calculator. Just make sure your calculator is at least scientific and knows order of operations. But anyway, one point on that function, on the g function, is going to be the point -1, -5. Okay. So here are some problems where it's just saying translate these into coordinate pairs. So all that means is that you know that 0 is my x because it was my input. You can think like it was inside the parentheses, it's my input. And -3 is my output, it's what I got. So all you have to do here is just rewrite it as a coordinate pair, x comma y, 0 comma -3. In this one, it's 7, -8. Super easy, I would hope. Just boom, there you go. For these ones, it's giving you two functions and just telling you to plug them in. You just got to make sure you're plugging them into the right one. So it's saying g of 4, so I want to make sure I plug 4 into the g function. So I'm going to do -3 times 4 plus 1. -3 times 4 is -12, plus 1 is -11. The directions, which can't really, are kind of spread out, say to write as a coordinate pair, so that's going to be 4, -11. For the second one, f of -2, I'm going to plug in -2. Now, I'm going to tell you, I do a lot of these ones on practice because every year, like so many people make the same mistake. They want to just write -2 squared minus, -2 plus 4. Especially when you're squaring something, just always get in the habit of when you plug stuff in to put it in parentheses, please. Because if you type that into your calculator straight, you will get the wrong answer because it's going to square the 2, but it won't square the negative. What you need to put is this, -2, like all together squared, minus -2 plus 4. Because negative, 2 squared is going to be -4, but -2 squared is +4. So anyway, this becomes 4 plus 2 plus 4, which ends up being 10. So that's the point -2, comma 10. Next, well, yeah, just make sure you're always plugging in with parentheses. I'm going to say it like 500 times. People are still going to do it wrong. It's frustrating, but it happens. Anyway, with this, the last thing is, in this case, it's telling you that g of x equals 4. It's saying the output is -4. So it's asking you, what is the input? What is x? So in this case, I'm going to take the g function and I'm going to set it equal to -4. Baba, stop that. Sorry. And then I just need to solve for x to figure out what it is, which is what we did the first week. So first, I will add 25 to both sides. Right? And then bring down my 3x, and then -4 plus 25 is 21. And then I just have to divide by 3. So the x would be 7. So when g of x equals -4, my input or my x should have been 7. So that means that g of 7 equals -4. Cool. This one, same thing, only I want to do it with the f function. So I want to take, when it says f of x equals, I want to take the actual f function and set it equal to 55. So I want 55, and really, it doesn't matter which side is which, just so you know, I could say 3x squared plus 7 equals 55, or I could put the 50, it doesn't matter which side goes which, just so you know. No, not now. So with these, it might freak you out because there's a squared in there, but I promise it's not that bad. So I'm still going to solve it like we've been doing. I'm going to get rid of my plus 7 by subtracting on both sides. So I get 3x squared equals 48. And then I want to get rid of the 3. So I get x squared equals 16. Now, sometimes you could probably just look at that and know what it is, but essentially what we're going to be doing is we're going to undo a squared, which some of you might remember is a square root. It kind of looks like a check mark box thing. Right, that's a radical symbol, but it's a square root. So I'm going to square root both sides. On the left, the square root of x squared just gives me x. And then on the right side, technically it's going to be positive and -4, because this equation is asking me, what are all the things, what does x equal to give me 16? Well, x could be 4, but x could also be -4, because either when squared will give you positive 16. So in this case, it's going to be plus or minus 4. So what that means is that f of 4 equals 55, but f of -4 also equals 55. So for either of those inputs, my output's going to be 55. That was the goal of what I was trying to do. They were saying your output was 55. What was your input? Well, it could have been one of these two things. Okay. So I know it's probably like a lot, but this shouldn't be too bad. This is more just like combining like terms. So this is doing operations with functions. So in this case, I have this function g and this function f, and this is just saying find f plus g. Literally all you're doing is you're adding them together. So I recommend putting them in parentheses. It doesn't matter so much with adding, but it will with other things. So I'm going to have 2x minus 1 plus x squared plus 3. And then all I have to do is combine like terms. So the first thing I have is my x squared, and that's the only one there is, so I'm just going to bring it down. Then I've got a 2x, which that's the only one there is, so again, I'm just going to bring it down. And then I've got two constants or numbers without variables. Add them together, and I get 2. So, ta-da! That wasn't too bad. Technically, that's like a pre-algebra skill, so you all should be good. Okay. Next, the next one is just subtracting. So it's the same thing, but make sure you're doing parentheses here because you have to do something called distribute the negative. So when I write it out like this, I have to take this negative and distribute it. It's kind of like having a negative one there that I'm distributing out or multiplying. So I'm going to bring down my 3x plus 3, and then negative x squared just changes to positive x squared, and then negative and a positive 4 gives me negative 4. So now I just got to combine like terms. X squared is my only one, so it comes down. 3x is the only one, so it just comes down. And then my 3 and my negative 4 go together to give me negative 1. The last one is multiplying, which is a skill from Algebra 1. So the function notation part is the new part. The rest of it should be stuff that you already know how to do, fingers crossed. If not, make sure you come to live practice and so we can practice this. But basically that dot is a multiplication symbol, just so you know. So what I'm going to do is I'm going to multiply these together. Now, over the years, I have given people options. You can FOIL this, which FOIL just stands for first, outer, inner, last. When you're multiplying two binomials, it's just a quick way to make sure you multiply everything times everything. You can distribute it where you multiply x times both and then negative 2 times both. But the way that most people seem most comfortable is something called the box method or the area method. So I'm going to make a box that is 2 by 2 because I have 2 terms and 2 terms. And I'm going to put my terms on the outside. And then basically I'm going to imagine each term going in a straight line, and when they run into each other, they multiply. So like 2x squared times x gives me, I just said the answer, 2x times x gives me 2x squared. I do that all the time. 2x times negative 2 is going to give me negative 4x. Then I've got x times negative 1 is just negative x. And then negative 1 times negative 2 is 2. Another reason why this one's nice is because in general, your like terms are diagonal from each other. So when I combine like terms, I'll get 2x squared minus 5x because that's like a 1. So I just add those together to get negative 5. And then plus 2. Final answer. So this is all stuff, like I said, this is all stuff we've done before. You should definitely be able to plug something in. You should be able to solve by now. And you should be able to combine like terms and everything. The new part this week is just doing all of those with function notation. So hopefully you all understand what I was talking about. If not, always ask questions during the live reads if you have questions. And that's it.